Welcome back to EKS Tech Show. Today we are going to discuss about the newly announced feature to the Amazon EKS, that's EKS Auto Mode. During the recent re:Invent, AWS announced the Amazon EKS Auto Mode. So this is a fully automated solution for managing compute, storage, and networking for Kubernetes clusters. And this is a long-awaited feature. Significantly reduces the operational burden by offloading most of the cluster management tasks to the AWS. So it's mainly designed for the individual and organization that face challenges in managing Kubernetes clusters due to limited expertise, bandwidth, or resources, and many more reasons. So now mainly the AWS key transformation is that Auto Mode simplifies the cluster management by shifting most of the operational tasks to the AWS, enabling customers to focus on their application while AWS handle the infrastructure. So let's have a look what it offers and how smooth the process of provisioning cluster and deploying application to the cluster. So I already logged into my AWS account and I'm in EKS landing page. So in general, so that basically by clicking that create cluster, we can generally start creating cluster by selecting all these parameters. By default now it's comes with the EKS Auto Mode, and we can select the Kubernetes version and the required IAM role and the VPC subnet, and we can start simply creating cluster. But as infrastructure engineers, we always go for the infrastructure as code. So let's try our usual approach by creating using Terraform script. I'm here simply using two modules. One is the mainly AWS EKS module, just to provision the EKS cluster, and to provide the VPC and subnets, I'm using the AWS VPC module, and in here I'm defining my VPC private public subnets and all the gateway and etc. And the special configuration that I need for the private public subnet for the EKS cluster. And I'm defining my VPC CIDR and region and the basic variables here as a local variable. Let's provision our EKS cluster in Auto Mode and see. So we can do Terraform in it. So I already did it, and as you can see it's already downloaded all the Terraform module, but I'll do it again. So it's I'll show you all the modules downloaded, and I'm going to do the Terraform plan. And even though we are using just two modules here, you can see it's going to create 59 resources. So the EKS module and the VPC module wrap around all the required underlying resources, as you can see here. So it's going to create all the VPC subnets and nets and security groups and all the components that we need for the EKS cluster. So you can leisurely go through all these resources and see what are the underlying components that we need for our EKS cluster. So as I'm satisfied with the Terraform plan, I'm going to apply Terraform apply. So as I already reviewed, I'm going to auto approve the plan, so I don't need to review the plan again. Usually by experience we know that to create all these dependencies and the EKS cluster, it will usually take 10 to 15 minutes. So yeah, we may need to wait. So I will pause the video till the cluster creation, and we can continue from there. Now we can see the name cluster appear in the AWS console, but still it's creating. Yes, now it just completed the cluster creation. Yeah, we can see cluster is active. Yeah, no health issues. Yeah, so if we just go to the compute resources, currently we can't see any nodes. If we just go to the pods, we don't have any pods. So in the cluster level we don't have any nodes yet. Yeah, so we just have to deploy something and see. Let's configure the cluster context, and we try to connect to our cluster. I just update my kubectl cluster context, and kubectl get nodes. We don't have anything yet. Yeah. So we have sample deployment here. So I'm going to just deploy some Nginx image with 3 replicas. So let's see how our deployment goes. So I'm just going to deploy it to our default namespace. kubectl apply -f deploy. So we're just going to apply this to our repeated cluster. Yeah, we just create the deployment. If you just now check the pods, we can see we have pending pods. Just 7 seconds, and if we just check the node, still we don't have any. So dynamically, so in here in the EKS Auto Mode cluster, for the node auto scaling, it uses the Carpenter. So when we have schedules pending pods in your cluster, it's going to evaluate how many nodes you need, and it's going to dynamically provision the nodes. So see, in few seconds we can see, just few seconds back, as soon as we create the pods, we didn't see any node. Now just after few seconds, it analyzes the how many pending pods we have, and provision the nodes accordingly. So as soon as the node get ready, we can see, yeah, now our Nginx pods are running. Let's refresh console. Yeah, now in the console we can see C6, a large node in our cluster, and we have three running pods. So you can try different experiment and see. So when you have increased replica count, so it will dynamically scale the cluster, and it will provision the nodes accordingly. So instead of having nodes running all the time, so as you can see here, the auto cluster, it will going to manage the node provisioning for us, and when required, and also when we see the OV, we can see the current Kubernetes version is 1.3, and when it's end of support for the 1.3, and we can update to the newer version anytime we need. So let's see here. Let's scale up few more pods. Let's say 20 pods. Apply the deployment. Let's see. Yeah, you can see many pending pods now. If we check the nodes, still we have only single node. Yeah, now we can see since we have many pending pods, it just added another node to the cluster. Yeah, as you can see, it's happening really fast, and we don't see much waiting time. As soon as it's in pending status, the carpenter take care of provisioning new nodes as required. Yeah, now all the pods are running. Yeah. Now since we have two nodes in 1.30 version, let's update it and see. Yeah, let's update it to 1.31 and see how smooth it can do the update process. Yeah, now it's in updating. Let's watch the nodes. In the cluster console, we can see cluster version is update in progress. Yeah, now we can see some changes in the nodes. I think usually it should provision new nodes with the new cluster version, and then migrate all the workloads to the new nodes. And and the node size also you can see. So the initially when we provision the three pods, so we got CXA large instance, and then we suddenly increase the it to 20 replicas, and then it realized that we need more capacity, and it's added extra large node. Here it provides some update inside, and it check all the flags that we need to check before the cluster update. Checking all the add-ons compatible with the new version, and check the version of probe proxy, whether we are using any deprecated API. That schedule remove with the new version. I can see now new version in the cluster info. Let's see what happened to the nodes. But still I can see the nodes are in the 1.30. Probably now it just complete the cluster component update, and now it's probably going to do the nodes update. Yeah, now we can see that it's provisioning new 1.31 nodes. Yeah, it just added one new 1.31 node, and workload will be moving to this particular node, and eventually it will do the same for the other node as well. I think now it's added new 2 nodes in 1.31, and it's going to eventually replace the 1.30. Yeah, this is just like a dream for the operational engineer. Just click of a button, it will manage all the version updates and OS patching and everything, and provision a new nodes for your cluster, and automatically transfer all your workloads by using defining the correct pod disruption budgets. You can make sure that your workloads are not impacted, and always serving at least a couple of pods for your workloads based on requirement. You can define what's the minimal disruption that you are expecting during this kind of maintenance activities. Yeah, so we will let yeah, it's I think almost done. Now if we check the nodes, yeah, now we only have the 2 nodes with the 1.31. Cluster update is completed. It took some time. I think initially it's did all the checks before the updates, and once validate everything, it's update the cluster, and then all the workload nodes. Yeah, and also we can see the get node pools. Then we are using this general purpose node pool here by default, and we can see the profile that the template basically. What are the node class and the instance categories we are allowed here. And the instance generation, architecture, and the OS. So I think this is the general purpose, the default node pool. And if we have any custom requirement that we need to define custom node pools, we can do that as well. Yeah, let's scale down our workloads and see the cluster behavior. Group CTL -f deployment. Okay. Group CTL records. Yeah, we don't have any resources now. You should see the resources ports. Nothing. Now let's see how long it will take to scale down the cluster. We just watch for the nodes. Yeah. I can see that new nodes are in not ready status now. Since we don't have any workloads now, we don't have any nodes as well, so it's remove all the worker nodes for us. From the cost saving perspective, this is a huge win for us. So when we don't have when the pod scale down according to your requirements and the traffic, your compute resources nodes also getting scaled down. Yeah, so there are many things that we can try it out with this EKS Auto Mode cluster, having different node pools and defining all the pod disruption budget, and also the persistent volumes, and also the exposing workload to the external internet using load balancers. So you can give a try and see how smooth to operate in the EKS Auto Mode cluster. So I publish this simple Terraform script link, and if you need, you can use this and try the same by yourself. So once you've done your experiment, you can just do the Terraform destroy to prevent charging your account. It will make sure it will destroy everything that you have provisioned for your EKS cluster.